This will be a video for section 11.2. We're going to be comparing data displayed in box plots. So this is going to be a lot like what we were just doing with we did dot plots before. But what we're going to do in this one is we're going to use box plots, which are the things that have a number line. There's a box, there's a line coming out, a line coming out, and there's a line in the middle. And what these box plots show us is where 25% of our data is, 25% of our data, 25% of our data, and 25% of our data. So the box plot, it has this middle here, and this is our median. This middle line is our median. We have a dot here. This is our least, and this end side is our greatest. And then this and this, these two lines, these are called our upper quartile and lower quartile. So we've got our upper quartile and our lower quartile. And we have used these already. So what we're going to do now is we're going to analyze them. We're going to look for patterns. We're going to compare box plots. So what this one I kind of drew here, let's say this starts at 0, goes to 10. So we have like a median at 5. This is about 7, and this is about 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would show us that half of our data is below 5, and half of our data is above 5, because that's where our median is. That's what a median shows us. That is our center here in green. The middle line inside the box is the median. It divides the data into two halves. We've got a lower half and an upper half. Next, we're going to look at the shape. What does this one look like? It looks pretty evenly spaced out. We've got 3 numbers here from 0 to 3. We've got 2 here, so there's a 3 there. There's 2 here. We've got 2 numbers in between 5 and 7. We've got 3, so it's pretty evenly spaced out. We might see some box plots that look something like this, where you've got a dot. One of your whiskers is super long. This probably means there's an outlier here. And most of the stuff's probably around here, but a whisker way out here would probably show us there's an outlier. Or maybe we've got a really tiny box here in the middle, and we've got outliers on both sides, maybe. So the shape of this one is pretty evenly spaced out. How do the whiskers compare? Well, in this one we just randomly drew over here. We don't have any notable things about the whiskers. We'd probably say the whiskers are about the same. When I say whisker, that's this line. Think of like a cat. It's got a whisker sticking out, a whisker sticking out. It's got a box here, so it's a little cat. His whiskers are sticking out to the sides. So that's what these are called, and that's what I'm going to continue to call them. We've got a box in the middle and 2 whiskers. Is the box large or small compared to the whole thing? Well, in this one, it's about a third, or it's 4/10 of our whole thing. We go from 0 to 10, and this is 4 wide. So the box is pretty decent size, but it's nice and evenly spaced out. I would say this whole thing is pretty evenly spaced out. I might say the whiskers are about the same length, and the box is about the same size as the whiskers are. Just whatever kind of details and patterns we're noticing. Center is the median. This median is 5. Half of it is below it, half of it is above it. And then the last thing, we're looking at the range. We're looking at the spread, which is 2 things. The range we're familiar with. We do the top number minus the bottom number. We do 10 minus 1, so this has a range of 10. But more specifically, because if we have a range like of this one where I showed there's an outlier, or this one here which might have 2 outliers, our spread, a better measure of spread is the interquartile range. It shows where the middle half of our data is, where the middle 50% of our data is, and it rules out those outliers. It finds most of the center of our data, and it's the box. It's the box, the front of the box to the back of the box. It's the upper quartile minus the lower quartile. It is still a range, so we find the top number, and we subtract with the small number. So the interquartile range on this one, we go from 7 to 3. 7 minus 3 is 4. So we're going to go into our math book, and I expect you to open up your page to this page, and we're going to go through quite a few pages here. This video might be a little bit lengthy, but it kind of takes a lot to explain all these. So here we have the number of points a high school basketball player scored during the games he played this season. They're organized in this box plot. So maybe not one game, but he scored from 15 to 30 points in games. That's actually kind of a lot. In the center, in our middle, he scored 21 points. And half of the games, he was less than 21. Half of the games, he was more than 21. Okay, so we're going to find the least and the greatest values. Wonder if I can get all this on one screen. Let's see. That's going to have to be it. We'll do it that way. So let's find the least and the greatest. Well, the lowest he got in a game was 15. The greatest that he got in a game was 30. Okay. This dot doesn't mean this happened only one time. This could have happened several times. I don't know how many games they played, but 25% of the time he scored between 15 and 17 and a half points. 25% of the games he scored between 17 and a half to 21. 25% of the time he scored between 21 and 27 and a half. And 25% of the time he scored between 27 and a half and 30 points. So part B, let's find the median and describe what it means. The median is 21. I know that because that is the middle line in the middle of our box. What this means is half of our data is to the left, is lower than 21. Half of our data is to the right. So let's say it divides. I'm almost going to say the same sentence right here. That's what we have here. It divides our data into two halves. Half is greater than 21 and half is lower. For part C, we need to just find and describe the lower and upper quartiles. Well, here's our lower quartile, and here's our upper quartile. So lower quartile, or we might call this or Q1. Okay, so this will be Q1, Q3, because our median is Q2. So quartile 1, quartile 2, quartile 3. This would be Q4. And the least here would be Q0. But we're going to mostly only see Q1 and Q3. So our lower quartile, or Q1, is 17.5. Upper quartile, or Q3, is 27.5. And to describe them, we're going to say half of our data is in between 17.5 and 27.5. Half, that's our box. That's this whole box. Half of our data is between 17.5 and 27.5. For part D, we're going to find the interquartile range, which is that new one there. Interquartile range shows where the middle is, and it tells us a range again. So we need to do the bigger one minus the smaller one. So we need to do Q3 minus Q1. Well, Q3 is 27.5. Q1 is 17.5. So 27.5 minus 17.5 is 10. So half the time, it's in between. Half the time he plays this game, in a game, he scores within 10 points here. between 17.5 and 27.5. And this interquartile range is a really good measure of the spread. I could say he usually scores between 17.5 and 27.5. All right. Make sure you get this page written. We're going to skip the next page, and we're going to go on to number 3 here, where we're going to compare 2 box plots. We're going to compare the shapes, the centers, and the spreads. So for the first part, for the shape, what we're looking for, are they evenly spaced out? How do the whiskers compare? Is the box large or small compared to the whole plot? So let's see. For group A, it looks like the range is a little bit bigger. They're a little more spread out. If we look at the boxes are pretty similar. Group A's box is a little bit larger than Group B's box. The whiskers, the right whisker here, these two are pretty similar. Group A's lower quartile whisker, lower 25%, is a little bit larger. So let's put that in a sentence. Group A, what are we even? Football players' weights by pound. Okay, Group A's box is larger than B. And we'll say the lower whisker is also larger. Lower whisker in A is also larger. And also, let's say in both, the box contains most of the data. In both, or how about the box is much wider than the whiskers? The box is wider than the whiskers. What that means is here's 25% of our data, here's 25% of our data, here's 25% of our data, and here's 25% of our data. We have quite a few people where we have, if we just look at these numbers, this is about from 250, 259, I mean, from here, it's about 259 to 312, 314-ish. We have the same amount of people in between here and here, in between 256 and 314 than we do in 314 to 334. I know it's kind of hard to understand what I'm saying here because these numbers are so vague and not very specific, but the amount of people that are in between here and here is the same as the amount of people that are in between here and here. So they're a little more spread out in our box. Next, we're going to compare the centers. The center is our median, so we'll say that Group B's center is higher than Group A's. Group B's center is higher. And then the spreads, let's look at the range. A has a larger range, goes from here to here. It's a larger spread, it's more spread out. Larger range. And now let's look at the interquartile range, which would be the box. It also has a larger box. And interquartile range. The range is larger, so is the interquartile range. So Group A is a little bit more spread out with the variation in football players' weights. There's a little bit more variety in Group A than there is in Group B. Next, we're going to go down here. I'm going to copy this box plot because we're going to have to compare this box plot with different box plot from the next page. And I think it'll be good if we look at them together. So we'll have this one here. So let's compare the shapes. And the book already does this for us, but I think it would be good if we talk about it. The shape, are the quartiles evenly spaced out? It looks like store A, the inner quartile, the middle 50% is pretty balanced, but the left whisker is way smaller than the right whisker. If we look at store B, the whiskers are about the same. Our first part of our box, our 25%, compared to this 25%, the larger part of the box shows that we have a little more spread out. We have a lot of number of team wristbands sold daily. We have a lot in between, like 48 and 52, a lot of them, because that's the same amount that they sold in between 52 and 65. So then our centers, if we look at store A and store B, well, store B, the center is larger, is higher. Typically in store B, they sell more. There is some exceptions to that. Store A had a better day every once in a while, but store B usually sells more wristbands. For the range, store A has a higher range. For the interquartile range, it looks like store A has a higher interquartile range as well. So B is a lot more consistent. Their data is squished together more than store A. Store A, they might sell 25 one day, and they might sell 77 in one day. Whereas store B, it's either between like 42 and 74. It's a lot more consistency. So we'll go ahead and get our next one. We're going to have to compare this one to those two. So I'm going to move my face here and paste this one in, hopefully get about the right size. A little too big, I think. 80, 20, a little smaller. All right, so now if we look at this one, it's not perfect, but this one is a lot more similar to store A. The medians are very close together. The upper whisker is smaller. Our middle 50%, our interquartile range, is about the same, it kind of looks like. It's just kind of shifted over to the left a little bit to get to A. So let's talk about the shape. Make me a little squeeze my hair right there. So what are directions for this problem? We're going to do this page, and then we're going to wrap this up. So number 4, we need to compare the shape, center, and spread of the data in the box plot with the stores A and B. So let's talk about the shape. The shape is very similar to store A, but the right whisker is a little bit shorter. So let's go ahead and say that. The shape, similar to A, but right whisker is a little longer. Next, we'll compare the center. Okay, the middle of our data, let's see. The center, this one was at about 43, kind of looks like. This one's at like 44, and this one's at 52. So A was at 43, B is at 52, and C is at 44. So the center is a little bit higher than C, but still less than B. So we'll say slightly higher than, forget the H and higher, than A, still less than B. And the last one, we're going to do the spread. So let's calculate the range The range of A goes from, that's about 77 minus 25. B, the range is from about 74 minus 25. Oh, nope, that's C. And B is about 73 minus 42. I'm mostly just estimating, but I think those numbers are pretty close. So let's figure out the ranges. 77 minus 25. A is 52. B is 73 minus 42, 31. And C, 74 minus 25 is 49. So we'll talk about the ranges. The range is less than A, but greater than B. Range is less than A, greater than B. Now let's look at the interquartile ranges. I'll do those up here. A, B, C. And I'll be like 10 minutes. A is the interquartile. It's going to be 55 is the upper minus 31. B, the interquartile, goes from 65 to 43. And C, the new one down here, we go from 60 to about 34. So let's look at the interquartile range. So look at the variation of the middle half of our data. 55 minus 31, A has an interquartile range. Half of its data is within 24 of itself. 65 minus 43, that's within 22 of itself. And 60 minus 34 would be within 26 of itself. So the interquartile ranges are actually pretty similar. IQRs are most of those pretty similar. All right. Again, to calculate the interquartile range, we do this minus this. So we did 60 minus 34. All right, so we'll finish this part up, and then we'll be wrapped up for this section. For number 1 through 3, we need to use the box plot that Terrence created for his math test scores and find each value. So the minimum value, the lowest score he got was 72. Looks like our lines are counting by twos, 70, 72, 74, 76, 78. And our maximum, the best grade he got was an 88%. Probably a percent, I'm not sure. The median looks like he got a 79. Usually, he gets about 79. Half the time he's above that, half of the time he's below that. The range, this person's score, he gets an 88 at best, and at worst, he got a 72. So the range here, 88 minus 72 is 16. So he's usually within 16. Okay. The interquartile range, so half of his data is going to be between inside this box, which is at 82, 84, so 85 is the right side of the box, minus 75 is the left side of our box. So the interquartile range is 10. So half of his data, half of his math tests are within 10 points of each other. All of his math tests are within 16 points of each other. He usually gets about a 79%, but it might be bigger, might be less. For 4 through 7, we're going to compare the heights of hockey players and volleyball players. And we're going to compare these. So which group has a greater median height? The median is the middle line. So who has a greater median height? Looks like volleyball players, which is at 74. Which group has the shortest player? So now we're looking at the least. Well, the hockey players have the shortest. Which group has an interquartile range of about 10? Okay, well, let's do some math. So let's do the hockey, and we'll do volleyball, and we're going to do the interquartile range. Hockey goes from 76 interquartile, so I'm looking at the upper part of the box and the lower part of the box. So 76 minus 66. Well, that's 10. Let's double check this one, make sure it's not also 10. Volleyball players, 76, 78. So we'll do 78 minus, because this is at 78, minus 68. Oh, that's also 10. All right, good thing we didn't stop. Both have interquartile range of about 10. For number 7, what information can you use to compare two box plots? Well, we can use the center. I'm not doing them in the same order as we had earlier. The spread and the shape. That is the information we can use to compare them. We can look and see, do we have a lot of people in between these numbers? Do we have a lot of people in between these numbers? Remember, each section of this box is 1/4 of our samples. So if we do 100 math tests, 25 of them fit in between here. 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 So just as a reminder, and this will be on your homework page, when you are looking for the shape, center, and spread, for shape, what we're looking at, is it really stretched out? Is it really close together? What does your box look like? For center, we're looking at the median. The median shows the middle point. Half of your data is to the left, half of your data is to the right. And for spread, I want both things calculated. I want you to tell me the range, which is the greatest minus the least, from the least to the greatest, so greatest minus least. And I want you to tell me the interquartile range as well, which is the upper quartile minus the lower quartile. That's all I got. So as always, let me know if you have any questions.